Welcome back everybody to the Ionic bonds, bonding basics. I'm now going to show you how some common elements form ionic bonds. We're going to start with looking at potassium versus fluorine. Here's what we're going to do to start. We're going to draw in the atom of potassium using its symbol. Potassium symbol, of course, is K. Do you remember the Lewis dot structures where we just learned how many valence electrons there were and we drew the dots for those? That's what we're going to use here. We're going to know that potassium is in the first group over there, so it has one valence electron. That's my one valence electron. Next, I'm going to draw in fluorine next to it. There's an atom of fluorine. We're going to draw my atom of fluorine by just putting in the letter symbol for a fluorine atom. And then we'll look to the periodic table to see how many valence electrons it has. And as I look over there, I see fluorine is way on the right side, and it's in the column that all has 7 valence electrons. So I'll draw in my 7 valence electrons. Okay, is this potassium happy? Does it like having just that one? No, of course not. It wants to get rid of that one, right? And fluorine is not happy. It's got 7. It would like to have 8. It would like to take on one right there. It's got a spot for it. So watch what happens. The potassium is like, here, take that electron. And now what we see is that... What?
Try the ladder, the vacuum.
Oh. So now what we see is that this fluorine will have 8 electrons around it. 1, 2, 3, 4, 5, 6, 7, 8. And this potassium that got rid of that one, well, does it have 0? Or, oh, the potassium, there's actually a shell underneath that valence shell that was already full. So the potassium kind of falls back to that original full shell. So now we see that both atoms is happy, which is good. Okay, that's step 1, drawing where the electrons go. Step 2 is going to be drawing out the oxidation numbers. We're going to start by, again, drawing our potassium, and then we're going to remember what's the charge on this potassium after it gets rid of that electron. Well, the charge is going to be +1 because it got rid of a negative charge. This is our oxidation number for potassium, the oxidation state of potassium. We're also going to draw it for our other element, fluorine. Fluorine gained an electron, which means it's getting one more negative charge to it, so it went from being neutral to having a -1 oxidation number. And then finally, we're going to redraw the correct chemical formula. We're going to start with whatever the positive ion was. It was potassium, and we'll go see how many potassiums did it take. Well, it just took 1, right? So we do K. We don't even write a 1 down here because it just K stands for there's 1 K. And then there's also 1 fluorine. So that is our correct chemical formula. So we're going to end up with our chemical formula over here. We're going to end up with our oxidation states. And we're going to end up with a drawing of the bonds. And we're going to do all 3 of those for every one of these. I'm going to do this one next, and then I'm going to kick you loose on the back side. Here's magnesium and iodine. We'll start with magnesium symbol, which is, oh yeah, Mg. We look to the periodic table, we see that magnesium has 2 valence electrons. And then we put in iodine symbol. We see that iodine is I with 7 valence electrons. Again, I looked at the periodic table to find that. And now we'll draw where the, oh, do you see the problem? Magnesium is looking to get rid of these 2, right? And it's got 1 that it can put to right there. And now, is this iodine going to be happy? Yeah, this iodine's good. But is the magnesium happy? It's not. It's got this 1 electron, right? So what we have to realize is that these reactions never happen in isolation. It's never 1 atom of magnesium with 1 atom of iodine, actually. It's going to be trillions and trillions and trillions. If you have a pile of magnesium or a pile of iodine, it's going to be billions and billions of atoms. So there are more iodine atoms present. And this other iodine atom that's hanging out over here that has 7 valence electrons is ready to take on that extra electron. Oh, look. Is everybody happy? This guy's got 8. This guy's got 8. This guy got rid of those 2 to have its full shell underneath. Everybody's happy. That's awesome. That's our drawing. Let's draw in our oxidation states. Oxidation states. We'll start with magnesium. Magnesium got rid of 2 electrons, so its charge went from being neutral to actually +2. I'm also going to draw in iodine's oxidation state. I'm looking at one individual iodine atom. It gained 1 electron, so each iodine atom became a -1 ion. And then finally we'll write in our chemical formula. And we see that it goes like this. It goes magnesium, and then I'm looking over here. It only took 1 magnesium, but it took 2 iodines, right? So it's magnesium iodine with a 2 down low and after the iodine to show that there's 2 of them. And that's my correct chemical formula. Your job is to finish this backside here. We've got 4 different elements, combinations. I'll give you a hint. That's the hard one. Okay, happy solving, everybody.